The first type of FRQ that we are going to look at is the accumulation function, which you know means for rates to come in and rates to go out. And so when you're looking at a rate and accumulation problem, these are some of the things that you have to be aware of, okay? So first of all, when I'm looking at this, you're going to notice most of the time it's in which some things are changing. Ooh, I think I need get a color for that. There we go. And usually there are two rates, one coming in, one going out. Many times this will occur in a calculator section. Make sure that if you see this occurring, that you take the functions that are given to you and store them in, for example, f sub 1 of x, store one of the functions and store the other in f sub 2. Because once they're stored, then you will not make calculator errors. Now the main idea behind this is that when you take the integral of a rate of change, it will equal the change in value. So the integral of a rate of change is the change in value. Now value of what? I don't know. It might be bacteria, it might be water, gallons, it might be grass clippings, it might be gravel, could be anything. Now the other point besides taking the integral of a rate is that many times you will be given an initial amount and then you're going to add some more to that initial amount. So we remember this with the fundamental theorem. So the amount that you're looking for, you take the initial amount plus the integral of the rate, because that will give you the change in the amount. Now what do you need to be able to do? First of all, they won't always state explicitly that they're giving you a rate of change. So you have to make sure you look at the units carefully, because generally the units will give you an indication that it is a rate. You will need to use the fundamental theorem to differentiate. Remember that when you take the derivative of an integral, it is the integrand. Also, many times you're going to have to explain the meaning of an integral. Now, they're very picky on these explanations. When you explain it, first you have to tell it's the change in the value. What is the value? Like we mentioned previously, could be many things. Secondly, you have to describe the units of the problem. So you'll have to say, is it gallons of water? Is it miles? Is it number of bacteria? And then the third thing you have to include is talk about the units of the limits. So like from the first 2 hours, this is how much it grew. Or from 25 minutes to 35 minutes. And the fourth thing you need to be aware of is many times you're going to have to find a max or a min. And then also find out when the function's decreasing. Now remember, max and mins are where the derivative equals 0, that's critical points, or it's the endpoints of the function. So that's where you're going to find your max and min. And of course, increasing, decreasing is where the derivative is greater than 0 for increasing and less than 0 for decreasing. Now let's look at a couple of examples. Now this first example is a no calculator. Many times these examples do fall in their calculator section, but I wanted to give you a look at both of them. So what I'm going to ask you to do is to read this problem and then in pencil solve it. Now you should be able to tackle all 4 parts because we are reviewing now. It's not new content. So I need to see in pencil you attempting all 4 parts and not taking any more than 15 minutes. When you are done attempting it, then you will correct it in colored ink. Now when I look at a problem like this, the first thing I do is I start underlining the facts. So you sell for $120 per meter. You have a fixed length, producing a portion of cable, and it varies from the distance from the beginning, okay? The reports the cost to produce a portion from the beginning is 6 square root of dollars per meter, okay? Note, profit is the difference between the amount of money received and the amount of money for selling it, okay? So it would be your selling minus your cost is your profit. Now answer A, B, C, and D. Okay, now I'm not going to so much explain the math here, but I'm going to explain things you need to look for in your points. First of all, integral. Do you have this integral set up correctly? Did you remember the dx? Do you have the correct integrand? Do you have the correct limits? Okay, and then the answer has to be correct, 2,500. Now B, you have to have the correct answer with units. Now there's actually 2 different units I'm seeing. I'm seeing cost in dollars, you must put in dollars, And then the other units is 30 meters to 25 meters. So you must have both units there and then express that this is the difference in cost between 25 and 30 meters. For C, you have to write a correct integral. Now they asked you to use the variable k, so that should be your upper limit. But remember, the integrand has to be a different variable because we're going to replace x with k. So this, in order to get the integral, you need to have this whole part correct. That's 1 point. And then the whole expression for the second point. Okay, D. Now this is where we talk about that you've got to show all of your steps. So first of all, you get 1 point if you clearly state somewhere that in order to find a maximum, you have to set the derivative equal to 0. So right here, you're showing that you took the derivative of p and set it equal to 0. That's 1 point. If you don't clearly state that, no point. Next, did you find the value for k is 400? Okay, answer, that's this value. Somewhere did you show that the total profit is $16,000? And justification, you have to explain verbally that the critical point for p is where p prime changes from positive to negative. Be brutal with yourself. Don't give points if you don't earn it. So for this FRQ, what was your score? Okay, and then I want you to identify specifically either what was your weakness or what mistakes did you make. Second problem. Now this problem is a calculator problem. Traditionally we see these problems show up in the calculator section. Now immediately when I see it's very verbal, and I notice right here I'm given the rate. So this is a rate of change right here. I'm going to put that function in my calculator immediately because I can see I don't want to keep retyping it. Ooh, also closed interval, 0 to 2. And the units are people per hour. No one is at the auditorium at t equals 0, so that means my initial value is 0, 0. That's nice, it's easy. And then the door closes at time equals 2. Okay, so please write in pencil, show your work for all 4 parts. I should see work for all 4 parts because you know how to do all 4 parts. Leaving it blank is not acceptable. Now let's make corrections to your FRQ. Please use colored pen in your corrections. Okay, first point is the integral. Now, is this integral correct? Do you have the dt written there? Do you have the correct function r of t and the correct limit 0 to 2? That's worth 1 point. And then secondly, did you get 980? Okay, for part B, it is essential, again, do you notice that? You have to set the derivative equal to 0. You need to show that. Okay, show that you're considering the derivative equal to 0. Now, of course, you're going to find these two values using your calculator because you're going to graph r of t. Actually, you might graph the derivative and then find the zeros. So you would analyze graph and find the zeros on your graph. Okay, so you've got the interior critical point. Now, in order to get the third point, you must have the correct answer with a justification. So the correct answer is the maximum rate occurs at t equals 1.362. That's the answer. But then the justification is you considered the critical point and you considered the endpoints. And from those 3 values, you realized that 854.527 was the greatest value. C, woo, this was a tricky one. So you had to realize that your fundamental theorem says that when you take the integral of a rate of change, it is the change in values of the antiderivative. So now what we are going to do is we're going to do 1 to 2 of 2 minus t rt dt using our calculator, and we get 387.5. So notice for the correct integral response, you could have either this first circle or the second one, and then you must have the correct answer of 387.5. Part D, they're asking for an average value. Remember, average value is the integral divided by the interval. Okay, so the number of people that came in were 980 total. And then the integral of 0 to 2 of the rate of change divided by 980 is this value here. So again, you get 1 point if you've got this integral set up, and then you get the second point for the answer. So now again, what was your score on this FRQ? And what were your weaknesses or any mistakes that you made that you learned from doing this FRQ?